Hello, grade 9 students. In this video, we're going to continue our chapter about genetics, part 5. And in this video, we're going to talk about the laws of heredity. Laws of Mendel. Mendel, it was the biologist that discovers the law of heredity. So first, Mendel talked about the laws of heredity. He used for this the peas, the wrinkled and the smooth peas for this. And Mendel, it was the biologist that started these laws, the laws of heredity. So it was the first one to talk about this. It was Gregor Johann Mendel. So Mendel, it was the first biologist to talk about the laws of heredity. Let's start with the laws of Mendel. The first law, it was law of uniformity of hybrids of F1. What does this mean? This means that all the hybrids, all the heterozygous of the F1, all of them, they are identical. For example, if we cross a black with a white, all the F1 generation, they are black, like one of the parents. So here, this is the meaning of all the F1, all the first generation, they are identical, and they have the same phenotype as well as the same genotype. So this is the first law of Mendel, law of uniformity of the hybrids of the F1 generation. All of them, they are uniform, all of them, they are identical, and they are the same. So this is the law 1, first law. Let's now move to the second law of Mendel, the second law of heredity. It's the law of independent segregation or disjunction of the traits or factor. What does this mean? This means that the traits or the factors of the hybrid of the F1, they separate independently of one another during the formation of gametes. What does this mean? This means that their union at random with other gametes of another hybrid F1, they determine the heterogeneity of the F2 generation. For example, if we cross F1 with F1, we're going to have the F2 generation. In the F2 generation, we're going to have different phenotypes and different genotypes as well. This is the meaning of the heterogeneity of the F2 generation. Moving now to the third law, law of purity of gametes. Purity of gametes meaning that it's impossible to find a certain gamete two alleles. So it's impossible to find in a certain gamete two alleles at the same time, whether they are either different or they are identical. So only one allele in each gamete. This is the law of purity of gametes. So activity 2, the laws of heredity, page 138 and 139 on your book. Let's start with this application. In this application, we're going to cross the P's that the Mendel used them in order to describe his experiment. So upon crossing a pure line, the meaning of pure line, they are pure. So they are homozygous of smooth P's with another pure line of wrinkled P's. So wrinkled, so all the obtained F1 generation, they are smooth, like one of the parents. So here we can determine that the smooth allele is dominant over the wrinkled, which is recessive. While upon in cross 2, upon self-fertilization, well, the meaning of self-fertilization is the self-cross. Upon crossing F1, crossed with F1, all the obtained results, we have 5 wrinkled and 15 smooth. So the first, this is the smooth P, and this is example about the wrinkled P. It looks like this wrinkled shape. So referring to the cross 1, the first cross, determine the dominant and the recessive. So you have to say which one is the dominant and which one is the recessive. We got in all the F1, all the P's, they are smooth, like one of the parent. So the smooth allele is dominant over the wrinkled allele, which is recessive. Which law is verified here? Always in the first cross is the first law. law of uniformity in the F1. So always in the first cross, always the first law is verified. Law of uniformity of all the hybrids of F1, since all of them they are uniform. All of them they have the same phenotype and the genotype. Indicate the genotype of the parents and that of F1. The parents, you should give symbols before you give the genotype, because you have to give the symbols and then you have to give the genotype of the parents and that of F1. So here, since all the F1 P's they are smooth like one of the parents, so the smooth allele is dominant over the wrinkled, which is recessive. Which law is verified? Always in the first cross, so always is the Mendel's first law, law of uniformity of all the hybrids of the F1. All of them they are uniform, meaning that all of them they have the same phenotype as well as the same genotype. Genotype of the F1 smooth they are pure and the wrinkled they are pure. But first we have to give the symbols. You have to give the symbols before you give the genotype. So SS for the smooth, WW for the wrinkled, since the wrinkled is recessive, and SW for the wrinkled seeds for their parents, and F1 they are SW respectively. As you know, you have to give the symbols. Let S capital be the symbol of the smooth allele over the recessive wrinkled allele. Let W small be the symbol of the wrinkled recessive allele with respect to the dominant smooth one. Now moving to the second cross, cross 2, F1 with F1. They want you to give the gametes produced by the F1. F1, they are SW. So they give two types of gamete. They give S and they give W. 50-50 or half-half. It depends. So either you can say 50% S and 50% W if you're working percentage, or 1/2, 1/2 if it's proportion or ratio. To which hereditary laws did you refer? State them. So here in the second self-cross, always use the second and the third laws. Second law of the Mendel, law of independent segregation or disjunction of the alleles. So the alleles, they separate during the formation of gamete. And the third law, law of purity of gamete, one allele in each gene. Calculate the proportion of the different phenotypes. We're going to solve this. So these are the gamete, 50% S and 50% W. Mendel's second law, we state them. Law of independent segregation of alleles, where all the F1 they separate independently during the formation of gametes. And Mendel's third law, law of purity of gamete. Each gamete carries only one allele for each gene. Now for the proportion. We said that whenever we have to work with the proportion, first step we have to take the smallest numbers and define all the numbers by this number. So 5 is the smallest. We have 5 and 15. So 5 is the smallest one. So we divide the wrinkled 5 over 5, we got 1. Smooth 15 over 5, we got 3. So we add them, 1 plus 3, it gives 4. So 1/4, it gives for the wrinkled. And the 3/4 is for the smooth. Perform the essential factorial analysis to verify the results of both crosses, cross 1 and cross 2. So the first cross, let's start. Steps of the factorial analysis, we have to start with the phenotype of the parents. So phenotype, male and female here, it doesn't differ, it's the same because they didn't mention the male or the female. So you can say the male is the smooth and the female is the wrinkle. So genotype, male cross female, smooth, they are pure SS, wrinkled W small, gametes of symbol gamma. So on the gametes we have only one, and here I'm going to work it in proportion because they ask you to calculate the proportion. So here S, it's 1/1, this is the proportion, and here only W small 1/1. Here we move now to the table of cross, and then we move to the table of results. Table of cross. In the table of cross, what do we have? we have this male and female. In the male we have S 1 over 1, and here we have W small 1 over 1. So S times W, it's SW. 1 times 1, it's 1 over 1. So table of results. Table of results, we have to move for genotype. It will give the phenotype. Genotype, it's SW 1 over 1. So all of them 1 over 1 will be smooth. So by this way we can determine or we verified the results. So you have to say therefore results are verified. So therefore results are verified. So this is for the first cross, for cross 1. This will be the genotype for the F1, it's SW, and the genotype will be SW, sorry, and the phenotype will be the smooth one. Let's move now to the cross 2. F1, F1. So in cross 2 we crossed F1 with F1. So what do we call this cross? It's called the self cross. Start the same. Factor analysis will start with the phenotype. So we have male crossed with female. Both of them, they are smooth. Smooth crossed with the smooth. Then we move to the genotype. Phenotype, genotype. The male and female, both of them, they have the same genotype as W crossed with SW. Since it's self-cross, both of them should be the same. Gametes of the symbol gamma. So here we have S and W. So we have S and we will have the W. Every one of these is going to be half. So 1 over 2, 1 over 2. And also here we have S, 1 over 2. And here we have also W, 1 over 2. This is the gamete. Now let's move to the table of cross. The table of cross, pay attention what you are going to do. In the table of cross, you're going to increase it. So it's going to be 2 boxes here and 2 boxes here. And we divided male and female. So table of cross, here we have S, W, don't forget to what the proportion, 1 over 2 and 1 over 2. Here we have S, W, 1 over 2, 1 over 2. So S times S, S. 1 over 2 times 1 over 2, it's like the math. 1 over 2 times 1 over 2, so it's equal to 1 over 4. So it's 1 over 4, numerator by numerator and denominator by denominator. S times W is SW. 1 over 2 times 1 over 2, it's 1 over 4. Also here, W times S will start always with the dominant, SW, 1 over 4. And W times W, WW, it's 1 over 4. So let's move now to the table of result. The table of result, we are going to divide it into genotype and phenotype. So in the genotype, we have SS 1 over 4, and we have SW 1 over 2, and we have W small 1 over 4. So here SS and SW, both of them, they are smooth. So here 3 over 4. How did I get 3 over 4? It's 1 over 2 plus 1 over 4. Half plus a quarter. It's a 3 over 4. And you can make the same denominator and you can add them. 3 over 4, they are smooth. And here 1 over 4, it's wrinkled. Why? Because WW, it's homozygous recessive. So it should be wrinkled, WW. By this case, you have to say, therefore, results are verified. Results are verified. Okay? Thank you, guys.